It was the year 1952 when America first caught the flying saucer fever. A rash of strange sightings was reported in the skies over Washington, D.C. Were those unexplained radar blips, unidentified aircraft, or something much more outlandish? The Washington, D.C. sightings of the summer 1952 are also known as the Big Flap. But it all started in 1947 when a search and rescue pilot reported 9 saucer-like things flying like geese in a diagonal chain-like line. Their speed reportedly exceeded 1,000 miles per hour. Within mere weeks, the sightings of flying saucers were reported in 40 other states. Later, the explanations were found. The sightings were either hoaxes or misidentifications of known aircraft and natural phenomena, but a few cases remained unexplained. By 1952, the UFO investigation unit called Project Blue Book had been founded. It was led by Captain Edward Rubbold. He and his team would have continued to investigate a few dozen sightings per month, but for the April 1952 issue of Life magazine, with an eye-catching headline, "There is a case for interplanetary saucers." The article made quite a convincing case. It spoke about 10 unexplained UFO incidents, claiming that the flying objects were extraterrestrial in origin. According to the Washington Post, after the appearance of the article, the number of UFO sightings grew more than 6-fold, from 23 in March 1952 to 148 in June. By July, the UFO mania was in full swing. All that was missing was a spark. And it happened before midnight on Saturday, July 19, 1952. An air traffic controller at Washington National Airport spotted 7 slow-moving objects on his radar screen. They were far from any civilian or military flight paths. He called his supervisor and joked about a fleet of flying saucers. Simultaneously, 2 other air traffic controllers at National spotted a bizarre bright light hovering in the distance. It suddenly dashed away at breakneck speed. At Andrews Air Force Base, located nearby, radar operators detected the same unidentified blips. Those were slow and clustered at first, but then they raced away at a speed higher than 7,000 miles per hour. One Andrews controller looked out of his tower window and spotted something he later described as an orange ball of fire with a tail. A commercial pilot flying over the Virginia and Washington, D.C. area saw 6 streaking bright lights resembling falling stars without tails. 2 jets were sent to search for the UFOs, but every time they got close to the locations shown on the radar screens, the weird blips would disappear. By dawn of July 20th, the objects were gone altogether. Ruppelt, the lead investigator of Project Blue Book, found out about the sightings just a few days later after flying to Washington, D.C. and reading news reports. He tried to get to National and Andrews to interview the radar operators and air traffic controllers, but wasn't allowed to take a government-issued car. He had to fly back to Ohio with nothing. In a few days, UFOs were back over the Capitol. The same radar blips appeared again. Radar operators were wondering whether those dozen or so objects could be caused by a temperature inversion. That's a common occurrence in DC's muggy, scorching summer months. It occurs when a layer of warm air forms in the low atmosphere. It traps cooler air beneath. In this case, radar signals can bounce off the layer at shallow angles and create an impression of near-ground objects in the sky. To be safe, 2 more aircraft were sent to chase down the unidentified targets. The jets raced to a location targeted by radar, only for the blips to disappear. Eventually, one of the plane pilots saw a bright light in the distance and gave chase. But even though he was flying at maximum speed, he didn't manage to overtake the lights. At a press conference, representatives of the Air Force offered the public some easy-to-swallow explanations, having opted for the temperature inversion theory. After that, UFO sightings dropped from 50 a day to 10.
In the middle of the previous century, flying saucers were constantly making headlines. America was going through a surge of reported UFO sightings. So it shouldn't probably come as a surprise that the American authorities, namely the U.S. Air Force, created a couple of short-lived programs. Those were Project Sign and Project Grudge, and their main goal was to look into that phenomenon. These programs were followed by likely the most famous of them all, Project Blue Book. It was a large-scale government study that lasted from 1951 to 1969. The initiator of this program was Major General Charles P. Cabell. He was a former intelligence director of the Air Force. Project Blue Book scrupulously gathered over 12,600 reports about people seeing bizarre, unidentified objects in the sky. After thorough research, it was determined that most of those had natural, quite mundane explanations. As for the rest of the reports, the members of Project Blue Book simply didn't have enough data to evaluate them. That's why support for their efforts dwindled. Officially, Project Blue Book was closed in December 1969. But apparently, it didn't make American authorities lose interest in UFO sightings. Because in mid-December 2017, the world found out that they had secretly launched one more UFO research program in the late 2000s. Accordingly to certain documents, American authorities spent around $22 million over a 4-year span on a project called the Advanced Aviation Threat Identification Program, aka AATIP. This project was started in 2007, and its main goal was to study UFO phenomena. Most likely, all this activity was triggered by the 2004 Tic Tac incident. That's when a few U.S. Air Force pilots spotted unidentified flying objects off the coast of California. They captured them on video. None of the pilots could figure out what these objects were. They behaved in a weird way, as if our laws of physics didn't apply to them. They were reportedly flying extremely fast and rotating in unpredictable movements. It looks as if after that incident, American authorities decided to investigate whether those objects could be identified or not. And if not, they were eager to know where they had come from and if they had been a threat. When the New York Times story about the new project broke, officials announced that the study had been terminated in 2012. However, there were people who claimed that the program was still ongoing. One of those was a military intelligence official running the program until they quit in October 2016. In any case, let's have a closer look at this mysterious program. Indeed, the areas of research funded by the project resembled things you could find in Star Trek. For example, one grant was for the study of traversable wormholes, stargates, and negative energy. This study was conducted by Eric W. Davis of EarthTech International, Inc. Another grant sponsored the research of invisibility cloaking. One more area of study included warp drive, dark energy, and the manipulation of extra dimensions. This research was conducted by a theoretical physicist and director of the nonprofit Icarus Interstellar. As we've already mentioned, all these studies received at least $22 million of funding, but this sum could have been much bigger. No one has revealed why or how these studies were given such huge grants under the AATI program. The results of the study aren't known publicly either. The criteria for choosing these fields of research could be that warp drives and stargates might be useful for extraterrestrial civilizations traveling interstellar distances to visit our planet. Still, some people are not amused that such questionable fields of study were receiving substantial government funding. One of the best and most convincing pieces of evidence that extraterrestrial civilizations have visited Earth could be the epic Nuremberg space battle of April the 4th, 1561. It was recorded either in 1561 or 1566. Different sources provide different information. All the retellings of this story focus on the woodcut picture and a vague summary of events that occurred that day. The emphasis is always on crashed spaceships and space battles. Almost everywhere you read or hear the story, it goes like this. the inhabitants of the city woke up early on an April morning and saw a staggering celestial show that looked like a real space battle. This story sounds even more convincing when you find out that some objects allegedly fought for quite a while. And some even crashed. You can see them in the lower right corner. Look at the picture once again. Orbs and crosses fighting, a giant arrow and bizarre tubes, crashing ships. Wow, that had to be a spectacular cosmic battle. To make it all more plausible, Hans Glaser, the artist behind the woodcut, was a very real person. He really did woodcuts, and this one is indeed from the time and place that it says it is, meaning it's not fake, and it does depict a real event that had its own witnesses. For all intents and purposes, it looks like very convincing proof of aliens visiting us, but don't get your hopes up. A superficial perusal of facts seems to confirm an extraterrestrial presence on our planet. But the most likely explanation is much more mundane. The Nuremberg 1561 UFO battle is just an atmospheric phenomenon called a sundog, or parhelion. A sundog is a concentrated spot of sunlight that can sometimes be seen to the right or to the left of the sun, or even on its both sides simultaneously. Sundogs often appear as a pair of patches of light with subtle colors at the same altitude over the horizon as the sun. They can have a variety of forms, from colorful spots to patches of light so intense and bright, it looks like there are two additional suns in the sky. Sundogs are weird looking enough to make it seem that something scary and otherworldly is going on in the sky. At the same time, it's just our planet's atmosphere or ice in the upper parts of the sky acting as a prism or reflective device. This prism makes the light from the sun or moon do weird things. This image can help you visualize the phenomenon. Apparently, Nuremberg had the perfect conditions for this phenomenon to occur. If you examine the depiction of this event and compare it with modern pictures and videos, you'll soon realize that a sundog is indeed a more likely explanation than the galactic empire paying us a visit. Let's find the proof of this statement in the translated description of these events and in the woodcut picture itself. First, the sun showed and was seen with two blood-colored half-round strokes, like the diminishing moon right through the sun, and in the sun, above, under, and on both sides, stood blood-colored and partly bluish, or iron-colored, also black-colored round orbs. Now here's the photo of a sundog. It has a halo surrounding it, and a red orb. And if we have at least one red orb, there could be others showing up during other events. Plus, keep in mind that sundogs are like prisms. So, depending on how light is reflected, there could be multiple colors present during such a phenomenon. Now, referring to circled plates mentioned in the description, those could be halos. For example, this sun halo looks vaguely plate-like, and it seems to be linked to other sun halos. And indeed, people have seen halos with multiple orbs. Some of the orbs could have taken a cross-like shape. If we watch some modern videos of sundogs, we might notice that the orbs on film are sun-colored. But since the Nuremberg event happened between 4 and 5 a.m., the clouds and the sun could have had reddish and orange hues. As for the fighting, it could be as simple as one shape moving a bit and changing shape along with the movements of the sun. It could have looked as if it was pushing the other shapes out of the way. Do you agree with the scientific explanation? Or do you prefer to think that Earth was visited by guests from a galaxy far, far away? Write your opinion in the comments.
If alien life exists, it may be way stranger than we can imagine. For some inexplicable reason, we've long assumed that aliens might be like us humans. But in reality, they're more likely to be some form of unfathomable AI. With dozens of billions of years of evolution, intelligence can develop in entirely new, unexpected directions. Humans might be near the end of Darwinian evolution. We no longer need to remain the fittest to survive. But the technological evolution of AI minds is just starting. Who knows, maybe in another century or two, we'll be overtaken by inorganic intelligence. So, the question is, are aliens more likely to be flesh and blood, like us, or are they something more artificial? Even though many believe that people are at the peak of intelligence,
It's possible that our species may just represent a stage on the way toward more artificial and advanced minds. And it can actually explain why space seems to be empty of similar forms of life. Perhaps an evolutionary transition to non-organic intelligence is inevitable all over the universe. Then aliens could be electronic descendants of once organic creatures that existed long, long ago. Such an idea gives us some exciting possibilities. If AI aliens were out there, they would act and think totally differently from us. Plus, they might not want to be detected. Non-organic intelligence may not need an atmosphere, so they might have already left their home planet. If they didn't need any special conditions, they would be able to make intergalactic voyages without having to fear for their lives. They could prefer to live in zero gravity because, in such conditions, you can build very large and very lightweight structures. For example, if you wanted to construct a giant gossamer-thin structure to harvest energy, it would be easier to do so in space than on a planet. They might not even need to live in orbit around a star. They could have innovative ways of getting energy we can't imagine yet. If their brains were silicon-based, they could realize that they needed less energy to process information at lower temperatures. So, they would move away from planetary systems to colder regions of the cosmos. They could even have periods of hibernation for billions of years. What if they had such a period waiting until the cosmic microwave background, the leftover radiation after the Big Bang, cooled down enough for them to function properly? We can't assume that these aliens would be a civilization either. On Earth, this term means a society of individuals. But aliens might be a single integrated intelligence, or they might be zombies, super intelligent but lacking self-awareness and inner life. In this case, they would be alive but unable to perceive themselves or the world around them. Alternatively, their advanced intelligence might allow them to understand aspects of reality we can't figure out yet. There are likely to be things in the universe that neither our mind nor our senses can grasp. But electronic brains might have a very different perception. Interestingly, these days, humans themselves are starting to use AI to detect alien life out there. After all, there are between 10 and 50 billion potentially habitable worlds in our galaxy alone, and looking for intelligent life is a hard task without some assistance. That's when the US-based research organization, SETI, Search for Extraterrestrial Intelligence, comes into play. This institute is looking for science and technology beyond the solar system. It could be evidence of intelligence out there. But it's a needle in a haystack kind of situation. Luckily, new instruments are helping the search. Artificial intelligence can both handle massive datasets and spot anomalies, which is transforming the hunt for alien intelligence. SETI, together with other research organizations, built an AI-powered software system called the Very Large Array. It consists of 28 large dish antennas spread across a desert plain. When it starts working, the AI will be able to process 2 terabytes of data every second. For comparison, modern laptops typically have around 1 terabyte of total storage. So, hopefully, these new tools will provide us with new, groundbreaking discoveries. According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radio panspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven. We could use one of the largest lasers in the world to detect alien spaceships. If aliens existed and managed to make a spacecraft as huge as Jupiter, our equipment could probably detect it using the ripples its warp drives would produce in space-time. You see, an enormous spaceship is bound to produce gravitational waves while moving around. You can read about a warp drive, also called a drive-enabling space warp, in science fiction. This device distorts the shape of the space-time continuum and is one of several ways of traveling through space. It's often described as similar to hyperspace, a faster-than-light method of interstellar travel. A spaceship equipped with a warp drive can travel at speeds greater than the speed of light by many orders of magnitude. But unlike some other fictitious faster-than-light methods of travel, like a jump drive, it doesn't permit immediate transfers between 2 points. Instead, it involves a measurable passage of time. A spacecraft using a warp drive would still keep interacting with objects in normal space, and produce gravitational waves too. That's why, if any extraterrestrial gigantic spacecraft traveled through our galaxy, the Laser Interferometer, Gravitational Wave Observatory, LIGO, in the US might be able to detect it. Its equipment could search for the ripples in the fabric of spacetime left by the spaceship. The bigger an object is, the larger gravitational waves it would leave. Planets, neutron stars, and even black holes produce quite prominent ripples. For the first time, such space-time ripples were directly detected in 2015. And since then, scientists have been getting better and better at spotting gravitational waves. New calculations published some time ago suggested that LIGO could look beyond conventional sources of space-time ripples. The authors of the study claimed that colossal alien spacecraft traveling at high speeds or pushed along by warp drives could also produce the telltale vibrations. The LIGO detector notices gravitational waves from the tiniest distortions they make in space-time when passing through it. The observatory consists of two intersecting L-shaped detectors, each with two arms that are almost 2.5 miles long. They also have two identical laser beams inside. The experiment is designed in such a way that if a gradational wave passes through our planet, the laser light in one arm of the detector gets compressed while the other expands. It creates a minuscule change in the relative path lengths of the beams arriving at the detector. At the same time, the warpings of spacetime that even the largest gravitational waves make are barely noticeable. They're often the size of a few thousandths of a proton or neutron. It means that LIGO is incredibly sensitive and requires precise maintenance and calibration. To check how far this sensitivity can stretch, researchers made calculations of the smallest object that would produce clearly detectable gravitational waves on Earth. Apparently, it would still be pretty big. To be detectable by LIGO, an alien spacecraft would need to weigh roughly the same as Jupiter, be within 326,000 light-years away from Earth, and travel at 1/10 the speed of light. Could spaceships of this scale and speed exist? It's unclear, but hopefully, scientists will be able to squeeze down the ship's size to slightly more reasonable proportions thanks to the increasing sensitivity of gravitational wave detectors. For example, in the mid-30s, the European Space Agency's Laser Interferometer space antenna is going to be deployed. Scientists also think that advanced alien warp drives could create gravitational wave patterns distinguishable from natural sources. If detected, these alien waves could prove at use with answers to how to reverse engineer the technology. All because the shape of the gravitational wave signal is dependent on the trajectory of an object. Once a burst signal is detected, we could attempt to figure out the qualities of the transportation mechanism used there based on the shape of the gravitational wave signal.
Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi Paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us, because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi Paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi Paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
AI can drive a car, design trendy clothes, give you emotional support, and it looks like it can also help us find answers to centuries-long mysteries. Researchers from Yamagata University Institute of Nazca and IBM Japan used a deep learning AI model to find new Nazca lines. Those are distinct white lines on the rusty red background that you can see from a plane while flying over the deserts of southern Peru. Scientists have tried to decipher the meaning of the Nazca lines ever since they were first discovered in the 1920s. There are straight lines, rectangles, triangles, and swirls. There are also some giant drawings. You can see a monkey, a whale, a condor, a hummingbird. The 4 recently discovered geoglyphs, which is the scientific word for those drawings, show a humanoid-like figure holding a club, a fish, a bird, and a pair of legs. What is the hidden symbolism of all that? And why did the Nazca people decide to draw a humanoid in the desert? And did they even know who humanoids were? Let's dig into history to find some answers. The representatives of the ancient Nazca culture created their famous lines more than 2,000 years ago. The geoglyphs have stood the test of time thanks to a dry climate and strong winds in the desert. Scientists found that to form the lines, the Nazca people scraped off the top layer of pebbles, revealing the contrasting soil beneath. The soil's color varies from reddish-brown to yellowish-gray. It makes it look like the lines are constantly changing appearance. It looks like the creators first made small-scale models and then enlarged them to create the full-scale designs we see today. In total, there are more than 800 straight lines, around 300 geometric figures, and 70 animals and plant designs. You can find the first mention of the lines in the 16th century Chronicle of Peru, where they were first described as trail markers in the desert. Since you can't really study the lines and their symbolism from the ground, those geoglyphs only became world famous only in the 1930s. It was the start of the era of commercial planes, so more and more people could witness the lines from their window seats and spread the word. During his research a decade later, Professor Paul Kosuk noticed that one of the lines aligned with the setting sun on the day after the winter solstice, which is the shortest day of the year. He supposed that the lines had some astronomical significance. German researcher Maria Reiche, who got the nickname the Lady of the Lines, supported the theory that the geoglyphs served as a calendar and some sort of astronomical purposes. She spent 40 years studying the lines and literally swept them inch by inch. She also moved into a small house close to the lines to protect them from unwanted visitors. And that's how the Nazca Lines mystery was solved. Just kidding. In the 1970s, American researchers began to question astronomical theory. In a region like Nazca, one of the driest places on Earth with only around 20 minutes of rain per year, water is a real treasure. So the straight lines and trapezoids could have something to do with it. They could have been an ancient version of Google Maps, pointing at locations for rituals that the local people organized to get some water and help their crops grow. The images of animals in the Andes region are also related to water. Spiders are thought to be a sign of rain. Hummingbirds symbolize fertility, and monkeys living in the Amazon mean an abundance of water. That could explain the choice of symbols in the desert, but there's no strong proof to support this theory. So the work on explaining the meaning of those mysterious geoglyphs is going on. In the 21st century, the Nazca Lines have become the research ground for archaeologists from Yamagata University. Masato Sakai, a professor of archaeology, together with others on the team, are using high-resolution aerial photography and drones to discover and catalog the lines. They found images of humans, camelids, birds, orca whales, cats, and snakes, most likely created between 100 before current era and 300 current era. Some of the images are around 10 to 20 feet long, and that's why they were pretty tricky to notice. The largest geoglyphs are 1,200 feet across, which is about the height of the Empire State Building. The researchers believe the Nazca Lines were a form of communication in the desert for their creators. The linear ones pointed the direction from valley to valley. The ones drawn on slopes seem to have been drawn along ancient pathways between settlements. Professor Sakai explains that discovering new lines is tricky. Some of them are so poorly preserved that it's hard to spot them in aerial photos. There are also irrigation systems and roads all across the Nazca region, and it complicates the task. And that's where AI comes in handy. The team showed it pictures of previously explored Nazca lines so it could learn what to look for. Then, AI went through tons of footage taken from planes and satellites and also laser data from previous surveys to identify the lines scientists hadn't found before. The system works 21 times faster than humans, and it made some curious discoveries. Scientists then traveled to the locations it chose to verify the findings. In 2019, AI helped to discover a humanoid-shaped character with a rectangular head who is holding a stick and wearing a headdress. It became a real puzzle for the scientists trying to understand the creature's role in ancient society. The little guy is neighbors with another famous geoglyph. It's a hermit, which is a subgroup of hummingbirds that lives in the forested regions of northern and eastern Peru. The largest of the recently found geoglyphs is a pair of legs. It's more than 250 feet across, about 4/5 as tall as Big Ben. Could be an homage to some ancient supermodel. The fish and the bird are around 4 times smaller. Why they are where they are is still a mystery. Listing new geoglyphs isn't the only way AI is helping scientists. It's doing a lot of good for astronomy. It analyzes vast amounts of astronomical data and uses its algorithms to identify patterns, classify celestial objects, and even predict new events. For example, AI models have been developed to detect and categorize galaxies, search for exoplanets, and identify rare cosmic phenomena. It also helped analyze data obtained by the Kepler mission to discover new Earth-sized planets circling other stars. AI is also transforming the field of chemistry. Machine learning algorithms can predict chemical reactions, discover new compounds, and optimize chemical processes. All of this helps scientists save a lot of time and resources in the labs. If you've ever written a thesis, you know that analyzing vast chunks of information can take forever. Now imagine you need to analyze the archives of the British Library's national newspaper. It's piles and piles of history. So, researchers are teaming up with the curators to develop special software that can analyze the vast amounts of data extracted from these collections. Computational linguists and historians will be able to delve deep into the past and get some insights into changes in society and culture. They'll focus on key periods and track how advancements in technology shaped various aspects of society. AI even helps in the conservation of seals. It's really expensive and challenging to monitor certain species of those cutie pies living in the sea ice zone. Using high-resolution satellites, researchers can now identify the seals in photos, which already helps. But manually counting seals across huge areas of ice is like putting together a jigsaw puzzle of a blue sky consisting of 1 million pieces. It takes a lot of patience, and different analysts come up with different results. Machine learning algorithms can be trained to recognize and distinguish seals in satellite imagery and count them automatically. Researchers can then use this accurate data to monitor seal populations over time and study their behavior and habitat more effectively.
Now, I don't want to spook you, but there's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Habitable constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we might all live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies, kind of like between my ears. They make our entire world look like a big sponge. Now, let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density, called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long period of time, creating massive structures, galaxies. Galaxies are arranged in huge walls and filaments, with enormous gaps in between, and these gaps are voids, also known as dark space. Now, these voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about 1/10 of the average matter density, which is why we consider them nearly empty. Usually, they'll have a diameter ranging from about 30 to 300 million light-years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands of light-years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yeah, it's basically a big dark vacuum. But even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our universe. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures. and scientists have spent many years trying to figure out what the thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness of about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that's possible, so scientists keep arguing over this one. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace on our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists call this the local hole. The discovery of the local hole may hold clues to explaining the Fermi Paradox. Maybe in this specific part of the universe, where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all of the sentient beings hang out somewhere beyond our supervoid. But that doesn't mean we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the Sun and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2, but if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life even in our solar system alone, not even mentioning all the planets and galaxies we've found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, Leaving the local hole probably wouldn't be a problem. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space. Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is: an asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kind of like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So, Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards.
Not unlike a giant cosmic blinker, a supermassive black hole 570 million light-years away flares every 114 days. Recently, astronomers have noticed powerful eruptions of light coming from the hole. The monstrosity is about 20 times the mass of the one at the center of our home Milky Way galaxy. So far, the only explanation scientists have is the black hole is ripping chunks of matter out of an orbiting star. It happens every time it gets too close. This discovery is rather exotic because no one has ever seen a black hole do something like that before. Usually, if a star comes close to a black hole, the space monster shreds it into thin strands, like spaghetti. After that, the black hole swallows most of the star's matter. The remains arc away in long, bright streamers. But not in this case. Every time the star approaches the black hole, it loses about 3 times the mass of Jupiter, and that's the largest planet in our solar system. This also results in a tremendous flare that astronomers can see on Earth. The flares are so regular and consistent that the researchers managed to predict several of them. They happened on September 6th and December 26th, 2020. A nebula is a cloud of dust and gas in outer space. You can see it in the night sky, either as a bright patch or, vice versa, a dark spot against some glowing matter. The Red Rectangle Nebula in the constellation Monoceros, or the Unicorn, is unlike others. Our universe has very few straight lines, and here you are, looking at a giant rectangle, which is a huge gaseous nebula, no less. And then, there's also the color, a bizarre shade of orange-red. Astronomers suppose the glow might be coming from some unusual activity inside the dust clusters. This activity is likely to be going on at the molecular level. The universe is around 13.8 billion years old, but HD 140283, a star informally called Methuselah, is apparently more than 14 billion years old. Even more paradoxical, the star has some chemical elements that are more typical for a second-generation star. Those are the ones formed from dust and gas left after the explosion of the first generation of stars. And still, the main problem is, how can a star be older than the universe itself? So far, the most likely explanation is an error in observations. It could make astronomers believe the star is older than it is. The star called Vega is relatively close to us, a mere 25 light-years away from the Sun. It's not the most usual star out there. It's brighter than it's supposed to be, and it's not round, but rather egg-shaped. Astronomers claim that's because the star rotates so fast, its shape changes. See for yourself. It takes the Sun 27 days to make a rotation, and Vega needs only 12.5 hours to turn on its axis. This speed also influences the temperatures on the star's surface. Its poles are several thousand degrees hotter than the equator. There's a supermassive black hole 250 million light-years away from Earth. It produces the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. The Fermi bubbles confuse astronomers to no end. It's not every day that our home galaxy blows bubbles that are hotter than 7 million degrees Fahrenheit. Coming from the center of the Milky Way galaxy, the spheres are made up of nothing but powerful gamma rays. It would be a bit less strange should one bubble stay inside the other, with both of them at the center of the galaxy's core. But the two giant spheres hover independently above and below the black hole at the center of the Milky Way. Even more bizarre, they touch and form an hourglass shape. It makes the entire structure look like the number 8. The bubbles themselves are well-defined and slightly sharp-edged. They're also breathtakingly enormous, spanning a total length of 50,000 light-years. Scientists have yet to crack several mysteries connected with the Fermi bubbles, like what can produce such extreme energy? It's as powerful as 100,000 exploding supernovae. Or, what's with the off-center nature of the bubbles? Something must be going on there, even though it seems that the bubbles surround nothingness. K2-141b, a planet outside of our solar system, seems to be not that different from Earth. If you visited it, you'd see liquid oceans evaporating into the atmosphere. Just like on our home planet, the vapor then condenses and gets back to the surface as rain. But instead of water, all this happens with rock. The surface of the unusual exoplanet is covered with lava seas. In most places, they're tens of miles deep. And since the temperatures on the planet reach 5,000 degrees Fahrenheit during the day, the magma in the oceans vaporizes into the atmosphere. After that, supersonic winds, moving at a speed of 1 mile per second, carry the rock vapor to the planet's night side. There, the vaporized magma cools down, becomes liquid again, and falls to the surface as rocky rain. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in 2 days, 15 hours, which means it travels remarkably close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet has huge volumes of water ice, known as Ice X. It remains solid despite blistering temperatures. Neutrinos are teeny, almost massless particles that can move at nearly the speed of light. They can easily pass even through metals and travel miles and miles without anything to stop them. You can be sure that some neutrinos are passing through your body right now while you're watching this video. These elusive subatomic particles get born in supernova explosions and in nuclear reactions inside stars. About 4,000 light-years away from Earth, in the constellation of Serpens, there's a bizarre planet. Astronomers think it could once be the core of a massive star, long gone now. 5 times the size of Earth, it seems to be one enormous diamond. The planet is denser than any other discovered so far and is made up of mostly carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Most stars move around the center of their galaxies following fixed orbits, but not HE 0437-5439. This 30-million-year-old star that appeared not far from the center of the Milky Way decided to set off on a journey. Astronomers think the star might have come across the supermassive black hole Sagittarius A star, and the space monster might have pushed the star out of the galaxy. It's now traveling through the Milky Way's outer halo, moving right into interstellar space at a speed of 1,600,000 miles per hour. Stellar halos surround galaxies and are home to stars and star clusters. This discovery turned out to be extremely confusing. Such short-lived massive stars, because tens or even hundreds of millions of years is a very young age for a star, aren't usually found in the halo. There, you can only encounter the oldest stars in our galaxy, those that are at least 10 billion years old. When disastrous magnetic field collisions occur at the sun's equator, they cause ginormous tsunamis of plasma. These tsunamis move across the star's surface at a speed of 1,000 feet per second. Such a tsunami can last for weeks at a time. They happen almost every decade. More than 7,000 light-years away from Earth, there is the Eagle Nebula. It's a young cluster of stars, just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, towering tendrils of interstellar gas and dust. They're also a part of the nebula's active star-forming region. Newborn stars are hidden in these wispy columns. Unlike their supermassive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. But even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims tons of micro black holes could have appeared right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that several mini black holes pass through our planet every day, totally unnoticed. Scientists think white holes might exist, even though none has been found yet. When some space object comes across a white hole, it can't enter it from the outside, but light and matter can escape from within the hole.